In this video, we will briefly go over the concept of titrations. So a titration basically is what we did in General Chemistry 1. There was one experiment where you had to titrate sodium hydroxide with vinegar. And from there, you were able to get the concentration, percent concentration of acetic acid, a chemical that's found in vinegar. So like that, titrations are basically an experimental procedure where we can find the concentration of an unknown, or we can figure out, in the case of acid-base titrations, which is what we're going to be studying. We'll do a lot of those problems in Gen Chem 2. We basically can figure out the pH. And so the titration reaction is basically involves a burette, which is a long, slender piece of glassware. We usually read the burette to 2 decimal places, and I like to fill it up to 0.00 so that when you add it incrementally, you can just read off the markings to get the volume that you added. So the substance that gets put into the burette is called a titrant. The substance that gets stayed here is called a titrant. And you just turn this little knob and you add incremental units of the titrant to the titrant. So you can add it at 0.5 milliliter increments. You can add it at 0.2 milliliter increments. The burette is not really accurate, so I usually tell students you can go kind of fast because you're not really looking to get exactly 0.50 mils or 0.20 mils, whatever increment that you're adding. So we read it to 2 decimal places. That's the only important thing for the volume readings in that contain the titrant, housed in a burette. The titrant just sits there, okay, it sits in the flask. And we have different combinations. So you can do a strong acid with a weak base. You can do a strong base with a weak acid, all the different combinations. And for an acid-base titration, what we're looking at is 3 points where we want to calculate the pH. One is before the equivalence point. That is where the titrant sitting in the flask is a little bit more in excess. At the equivalence point, so that you keep on adding, you add 0.5 mils or 1 mil, and then another 1 mil, another 1 mil, whatever increment you're adding, up to a certain point where all of the titrant reacts with all of the titrand. And when the concentrations are equal, we call that the equivalence point. So at the equivalence point, we're going to use the back reaction in our acid-base equilibrium reaction. Once again, we'll have practice problems dealing with this. And then after the equivalence point. After the equivalence point, now the titrant is in excess, or the titrand. A lot of acid-base titrations, we use an indicator or a dye. The indicator or a dye basically changes color. So once you reach an equivalence point, it will change color. Or once you reach after the equivalence point, it will change color. That's when you really know the reaction has happened. So the titrant is going to react incrementally at some volume increment. To get the total volume, you just read off what was in the burette. That's why I usually like to tell people to fill up your burette to 0.00 milliliters. There's many other types of titrations. There's redox titrations, potentiometric titrations, and titrations that involve formation of complex ions. But in Gen Chem 2, we're really focusing our attention on acid-base titrations. This is the experimental setup, and we're going to do lots of problems where we have different combinations of the titrant, which are strong acid, strong base, with the titrand sitting in the flask, weak acid or weak base. We can flip and do all sorts of different combinations.